This program is brought to you by Emory University.
Imagine that you are a water molecule and you're in a glass of water and ice, and you're right at the boundary between the ice and the water. So a question you could ask is, how do you know if you're an ice molecule or if you're in the water? How do you know which phase of matter you belong to? And of course, it's very easy to distinguish between ice and water on a large scale, but if you're right at the level of a molecule, maybe it starts getting confusing right at that boundary. What we did was an experiment with small plastic particles in a liquid, and the particles themselves are analogous to the molecules in the water. And they can form into crystalline arrays where they form hexagonal layers, or they can form into liquid-like disordered structures. And we made a system where the two of them were put together. So we had a boundary between a liquid phase and a crystalline phase, but we could see that with the microscope. So the experiment that we did was to look at this interface between the liquid and the crystal and see how it looked over time.
I was looking for that transition. I wasn't sure how it was going to look, because I had looked how the colors move in the liquid and I had looked how they behave on crystal, but I wasn't sure what it would look in between. It was like amazing thing that had ever happened to me, like winning the lottery, because it took so much effort and so many days and so many trials until finally I got it.
What we found was that, in fact, it's not very confused, that there's a very sharp interface between liquid and crystal, and that maybe the zone of confusion is about 1 or 2 particle sizes across. So there's maybe a layer of 1 or 2 molecules thick where it's not completely clear if you're a liquid or a crystal. But other than that, it's very, very unambiguous. So this idea of the intrinsic interface was first discussed in 1965, and people have believed in this idea for a long time. These are the first experiments to visualize the interface, so we could really directly go in and say what's the details of this interface and exactly how thick it is. So that is the crux of the experiment that Jessica Hernandez-Guzman did.
The preceding program is copyrighted by Emory University.